Okay, this is latest paper, February, March 2022. Paper is 1-2. I have already solved for you just to save your time. So look at the question number 1. Simple question is, what could not be a measurement of a physical quantity? So do remember, physical quantity is a quantity which can be measured physically and it has unit, but we have to select the answer, which is not a physical quantity, means it has no unit. So A option, 10 Kelvin. So yes, it's a unit for the temperature. Now come to the B, 11 joule per Newton per meter, and joule for the work. So it's work divided by Newton per meter, and the work is measured in Newton meter because the work unit is joule. So joule is Newton meter divided by Newton meter cancelled, no unit. So B is the option because of B has finally no unit. So B is not a physical quantity. Suppose we check this C, this Pascal for the pressure, meter cube for the volume, and divided by Newton mean the force. Do remember, pressure multiplied by volume is equal to energy is equal to work. So it is work divided by force. When work is F into D, then work divided by force is equal to distance. So this C is the distance. It's a physical quantity. And then simple this 25 terameter. So definitely this distance. So we have to choose it's not a physical quantity. So the answer is B. A, C, and D are physical quantity, and B is the answer because it's not a physical quantity. Number 2, a computer memory stick is labeled as having a storage capacity of 120 gigabyte. The letter B stands for the byte. What is the equivalent storage capacity? So this 128 giga can be written as 128 10 power 9 byte, and 1.28 can be written as 1.2 into 10 power 2 into this 10 power 9 byte, and 9 plus 2, it becomes 1.28 10 power 11. Simple answer is B. So the question number 2, answer is B. Now come to the third one. A man of the mass 75.2 kilogram. This is the actual mass of a man. So this is a true value. Uses set of the weighing scales to measure his mass 3 times. He obtained the following readings: 80.2, 80.1, 80.2, reading 1, 2, 3. Look, these readings are close to each other. The only difference is 0.1, either plus 0.1 or minus 0.1. So these readings are very close to each other with the difference of 0.1 kg. So they are precise because they are very close to each other. But these values, 3 values, are far from the actual value, from the true value. So not accurate because they are not close to the true value. So the answer is D. Yes, there is a precision of 0.1 kilogram plus minus, because the reading are very close to each other within difference of 0.1, and they are not accurate because the difference of 75.2 and 80.2, 80.1 is not 0.1, is larger than this. So the readings are not accurate but precise. So D is the answer. Question number 4, which statement about the scalar and vector quantity is correct? Definitely scalar has magnitude and unit. Vector has magnitude, unit, and direction. So the B answer, because the scalar quantity has magnitude but not direction. Simple answer. Number 5, how can the acceleration of the object be determined? Yes, if time is plotted at the x-axis, the speed velocity at the y-axis in the graph, then the gradient of the graph is equal to acceleration. So we have option here, D. So the gradient of the velocity time graph is the acceleration. So D is the answer. Number 6 is, A sprinter takes a time of 11 seconds to run 100-meter race. Mean total distance covered is 100, total time taken is 11. But she first accelerates uniformly from rest. From rest mean the initial velocity is 0. Uniform acceleration mean the constant acceleration. And for this, the final velocity becomes 10. She then runs at a constant speed of 10 until the finish line, mean the rest of the time speed is constant. What is a uniform acceleration? Okay. So when we will plot the graph, sorry. So velocity at the y-axis, time at the x-axis, initial speed is 0 from the rest. So uniform acceleration, and after some time, suppose x second, its speed becomes 10. And then for the rest of the time, mean the total time is 11 x seconds for the uniform acceleration. The rest of the time will be 11 minus x, the speed is constant. So this is triangle plus a rectangle. Now, the total distance covered is 100, mean the area under the graph is 100. This area is divided in two parts. First, area of the triangle, half base into height. Then area of the rectangle, length into width. The sum of these two is 100. So it becomes 5x, 11 times 10, 110, minus 10x is equal to 100, minus 5x minus 10x is 2. And this time is 2. This time is 2 seconds. So here in this triangle, the change in velocity is 10, and the time taken is 2. So the change of velocity divided by 2, the acceleration is 5. That's why the D is the correct answer for this 6. Now, question number 7. A single horizontal force F is applied to a block X, which is in contact with a separate block Y. It means actually this F force is exerted on both because both are attached. The block remains in contact as they accelerates along the horizontal friction surface. Mean they are in contact. If the force is constant, their acceleration is constant. Air resistance negligible. X has greater mass than Y. Mean both are not equal in mass. Which statement is correct? Number 1, acceleration of the X is equal to the force F divided by X. No. The acceleration of X is equal to the force. Look, acceleration is equal to total force divided by total mass, not the mass of the X alone. So A is wrong. Because when we will divide total mass over F, then acceleration is calculated. So A is wrong. The force that X exerts on Y is equal to F. No. Force that X exerts on Y is equal to F. Do remember, when acceleration is constant, and F depends on the mass. The F is applied on the total mass, and X is exerting force on the smaller mass, meaning the mass of the Y is smaller. So that's why the force exerted by X at Y is definitely smaller than the total force, because the difference of the mass is F total for the total mass, and the force of X on Y is for the mass Y only. So this is wrong. The X is exerting force on Y smaller than the total force. So B is wrong. Next, the force that X exerts on Y is less than F, definitely, because the mass is smaller than the total mass, so force is smaller. And the D, the force that X exerts on Y is less than the force exerted that Y and S. No, not less, equal, because Newton's third law, action and reaction are equal. So X force on Y and the Y force on X definitely smaller than F, but both are equal. So C is the option. Next, question number 8 is, a car of mass 750 has a horizontal driving force of 2 kilonewton acting on it. It has forward horizontal acceleration of 2. Mass given, driving force given, acceleration given, and here the resistive force required. Look, driving force minus resistive force is the resultant force, which is equal to MA. So driving force 2 kilo mean 2000. Resistive force, suppose F, mass 750 to 2. So this is 1500. So 2000 minus 1500, it's 500. That's why the answer is A. Move to number 9. An object falls freely from rest in vacuum. The graph shows a variation with time t of the velocity. So initial velocity is 0. Gradient is constant. Mean throughout the fall, the gradient is g, mean 9.81 meter per second square, or Newton per kg. Which graph using the same scale represents an object falling in air? So definitely, when the object will fall in air, its initial acceleration is this, but gradually acceleration decreases, and finally it becomes 0, because when speed increases, air resistance increases, resultant force decreases, acceleration. Initially, the acceleration is 9.81, but final acceleration is 0. So look at A. Acceleration is not decreasing because the line is straight, so this is not the answer. Initially, look, the gradient is infinity because the line is vertical. No, its acceleration is not infinity. It's at a fixed value, 9.81, certain value. So B is wrong. C, yes, it has some gradient, which is gradually decreasing. And finally, it is going to 0. So this is the answer. And here, initially, look, the gradient is 0 because the line is almost horizontal initially. So acceleration initially not 0, it's 9.81. So D is the wrong answer. So the correct option is C. Correct one is C. Number 10 is a rock of the mass 2m traveling in the deep space at the velocity v explodes into two parts of the equal mass. Mean after explosion, the masses are m and m. One of which is then stationary. Mean after explosion, one of the mass is stationary. What is the kinetic energy? So first we will find out the velocity of the mass m after explosion. So according to law of conservation of momentum, m1u1, m2u2 is equal to m1v1, m2v2. So initially, single object. So no M1, no M2U2, single object. So M1U1, just one before explosion. So M1 is 2m and its velocity is v. So the initial momentum of the single object is 2mv. Later it is divided into two parts of equal mass. So m1v1 plus m2v2, but the second mass is stationary. It has no momentum. So the first part, its mass is m and velocity v1 is unknown. So when m cancels with this, so its velocity v1 becomes 2v, mean the double of the initial. Now we have to calculate the kinetic energy of the moving part after. So kinetic energy half mv square, 1/2. After explosion, the mass is m and the velocity is 2v, so 2v square. So it becomes 1/2 m, and 2v square means 4v square. 2 1s are 2 2s are, it becomes 2m square. So D part is the correct answer for this question number 10.